you make a product by removing the metal. Yes. I don't want to, yeah, let's go. Then one definition for bioprinting. So the ASTM defines bioprinting as a, इसका next PPT लेना है मुझे. Better is I get a laptop. वही होगा. Next PPT part 2 का ये PPT पे आइए. USB part 2. हाँ. So just very briefly, I have told you the many parts which I left there was that about the in the additive manufacturing technology, we have 4 technological platforms. The first platform is your 3D printer, then software, then materials, and then your simulation and modeling platform. So, right. So one by one. This is what I am going to cover here. And this is about the 3D bioprinting. We call it bioprinting. And it is again a technology that uses 3D printing analogy to create structures from living cells and biological materials. And the goal is to produce tissue-like structures, and that very much similar to the natural biological process. Here, what we have is this a bioink. A bioink is a printable material, and it is basically cells, human living cells, and they are suspended in a scaffold forming substrate. Scaffold is basically a type of a container that is in which this bioink is put, and the bioprinter is a machine which uses method like extrusion, inkjet, laser assisted deposition to place material precisely. This bioprinter is similar to 3D printer. What we have FDM technology, or your FDM is something like extrusion technology, and then inkjet, binder jet technology, and then you have a deposition by laser also. Then about the scaffold is generally made from the support cells, and that is they grow and organize. Then we have a post-printing maturation. Post-printing maturation is that the printed structures, they are further cultured so that cell can grow from connections and form connections and mature into. So this is the broad area where bioprinting applications are being made, and the very basic one is the tissue engineering. We are creating the upper part of the screen, not the complete screen. Then some type of cartilages, bones, and blood vessels. Then we are doing the organ modeling. That modeling means that you print a similar type of skin or organ for drug testing. And then disease search, like you are again printing something which is similar to a tumor or some disease. Then what we are doing is that is grafting the implants with medicines. And the long-term goal is a fully functional transplantable organ, kidney or heart, which I think will take decades. And the current state is that we are gone into simpler structures. So the first is the skin and burn treatment. Here what we do is that the upper part of the skin, when it got burned, which is there we print again with the help of the body cells. So there are two main approaches. First is lab grown. Lab grown means you grow the skin inside your lab and then you graft it. So what we do is that we have skin substitutes which are again printed layer by layer, and then again they are grafted. See, they are grown as a sheet, and not grown means the human body cells are taken, they are again put to a catalyst in petri dish, and then they are grown as a sheet. Sheet means that with the help of a scaffold, and then they are put again on the place where the bone, where the skin is basically having burn. Then there is directly printing from the wound, and there are printers available which can directly print on the wound. So there is a robotic bioprinter which is depositing bio ink, and which is basically a mixture of a patient own skin cells, and then we have catalyst, we call it growth factors, and a supportive gel. Gel is generally a collagen, fibrin, or sometimes hyaluronic acid based substances, and they are put on the wound and mapped through a printer. So we have cell collection from patient skin, then bio ink preparation, printing layered on the wound, and the maturation. Maturation means the tissue grows. Bioprinting is basically to promote cell proliferation and extracellular matrix formation. This is what the steps which are required in a bioprinting of skin. Wound को assess करते हैं, and after that you scan through 3D scanners. 3D scanners are again which are used for the ordinary additive manufacturing platforms. And then what we do is that from the scanned wound data, we make a patient-specific 3D digital model. And from that model, we make a scaffold, and then bio ink and cell preparation is done, and then layer by layer printing is done precisely. ये थोड़ा अगर मैं समझ गया थोड़ा सा ना, नहीं इसके ऊपर या हाँ, बट साइड से आया हूँ ये. Then the next step is vascularization. Vascularization means that you are creating channels for blood flow, and you stabilize the printed construct through a suitable cross-linking. Then you go for a tissue maturation, and then the wound testing and regeneration and remodeling. This is about this cell. I am going a bit fast because they need a lot of understanding about the human anatomy. If you know the skin layers, then only you can understand how the printing. But I am telling you that only the first skin, the top skin is being printed, not the complete skin. Complete skin has 3 layers, major layers, even sometimes 4 layers, but only top layer is being printed. Then the bone regeneration. Bone regeneration means that the bone is a load bearing organ, and it needs strong mechanical integration with the body along with the cell growth. So bioprinting approaches it by combining a structural scaffold and with the living bone forming cells. Again we use an imaging. Imaging is done through CT or MRI. CT, MRI, they try to understand what defects are there in the bone. And then we go for a scaffold. Scaffold is again you put around the place where there is a defect. And then bioink again made from the cell of the human body. Then you go for layer by layer printing by default, by depositing scaffold matching the defect exact geometry. After that, we go for the implantation and integration. This is what happens with the bone. There is a defect, and on this defect you put hydrogel, then you put a scaffold on this, and then a tissue structure is being made. What is happening is that body itself heals and you assist in the healing process. Bioprinting tackles bone regeneration by combining mechanical structure and the biological repair into a single printed object. It solves two problems. One is the bone defect, and second is the physical support that area immediately. I will tell you that some of the bones are being printed. Like if you have a bone which is like your chest bone, chest bones are being printed, but the problem is bone has a structure which has lot of porosity, and everywhere they have a different strength. It is very difficult to have some material like that which has porosity and differential strength at different place. So what we do is generally it is done by peak polyether ether ketone, and polyether ether ketone, they print a bone like a structure and which is implanted in the chest. When your chest bones are getting damaged, so that bones are put, and they are put with a nano material, because the nano materials improves their acceptance. Most of the material which are printed, they are not accepted by the human body. And that's what the problem is, that in this skin or bone printing, generally we are using body own cells. We are not getting cells from outside because the body may reject that cell. So this is what how the bone printing addresses the bone regeneration. Regeneration means that there is a defect and that defect is taken out. आपकी bone में there is some problem that was taken out, and then you regenerate that bone. Regeneration means that when there is a bone and you have taken out some part of the bone that was malignant or there was some problem with that bone. So you put a scaffold around it, that what shape to be given to that place of the bone. Then you grow using the cells. So you have to first match the exact shape of the defect, and for that you need a CT MRI. CT MRI, they give you very minute details, and then that scanning gives us a digital model. There are software like Mimic which can convert that CT MRI data into a 3D data, and that 3D data is used by the printers. And then a scaffold that mimics real bone. Scaffold is again made by the cells. Sometimes it is made by the chemicals which are in neutral or inactive, like calcium phosphate, ceramics, their compounds. And these compounds have a similar properties like bone, but they do not create problems for the growth. So this structure gets both strength and cell recognized and can attach to. See why you are so much concerned about bone regeneration, because what has happened in old age in many people, when the bone get broken or there is some defect, the bone cannot take load. See, if not taking able to load, then we have a problem. So third is what we do is that we embed living cells directly into the structure, and then generally stem cells are used. Stem cells are the basic cells and they are taken from the bone marrow of the patient. And generally bone marrows are also in the dental area also. Then you create a temporary dissolving framework. Dissolving means that scaffold is going to dissolve automatically when the bone is healed or the complete regeneration takes place. So this is biodegrade, and that is the same rate by which the bone is formed. So, and then bioprinting mein the best thing is that since we are using the same cells of the human body, so there is low rejection. The body does not reject the cell, and the regeneration is stable. And what has happened in many cases, even in these cases, when we have put peak bones. Peak means polyether, ether, ketone. There are advanced peak bones are also there. When they were put into body, after 10 or 12 years, they started creating problems. There was some allergy to the patient. So it is not that the patient rejection is on the very stent. Rejection means the body is not accepting the foreign body. Foreign body, आपकी human body is not accepting foreign body, and that is generally other people skin or other people cells are not accepted. Right? So donor is the concept. So, see, we are also started